Now we are discussing about propagation delay. What is this propagation delay? Why we use this propagation delay? When we take a digital logic circuit, irrespective of whether it is unipolar or bipolar, saturated or non-saturated, whether it is diode transistor logic, transistor logic, whether it is emitter coupled logic, ECL, we want to know what is the speed of this digital logic circuit, how much fastly it can give the output. That parameter can be known by using the propagation delay. As the name suggests, propagation delay. It gives the speed of the digital logic IC. So how can we define this propagation delay? If we send a pulse to any digital logic circuit, I am sending a pulse to a digital logic circuit. This is an IC. Remember, this box does not mean there is a box, I am sending some digital pulse to the box. This is an IC. Definitely this is made by using either unipolar or bipolar, any technology. I am sending one pulse. Now, what is the time taken by this digital logic circuit to send this pulse from this end to other end? So the mean time we are calculating. Sir, first time the pulse taken, the time is example some 10 nanoseconds, sir. Second time 9 nanoseconds, sir. Third time 11 nanoseconds, sir. Okay, what is the mean? 10 plus 11 plus 9 by 3. That is the propagation delay. When we go to the manufacturer, he will, whenever he is giving this IC, he will specify this is the propagation delay of this. So the propagation delay is defined as the mean time that is taken by the digital logic circuit to send this pulse. So whenever we are taking a pulse, the mean time taken by this pulse to travel through this digital logic circuit is called as a propagation delay. No, sir, it is a little bit confusing definition, or we need some more clarification. Okay, there is a second definition. What is that second definition? That is saying, okay, take one digital logic circuit, give some input. Okay, sir, I have taken digital logic circuit. Again question, sir, whether it is bipolar or unipolar, anything is okay. Sir, I have taken bipolar, whether it is saturated or non-saturated, anything is okay. In the saturated, whether it is TTL or resistor transistor logic or direct coupled transistor logic, anything is okay. So any digital logic circuit you can take. Now you are giving input. Now you are getting some output. When we change this input, now I am trying to give another input. If it is 0, I am trying to change to 1. If it is 1, I am trying to change to 0. The state of the input I am changing consciously. Now when I am changing the input, we are expecting the output to be changed. Now we are asking, so when we change the input, what is the time taken by this digital logic circuit to change the output? So we have already changed the input. But what is the time taken by the digital logic circuit to change the output? That time we are calling as a propagation delay. Example, if there is an AND gate. If it is example 0 and 1, the output is 0. Now we have given the two inputs. Now we have changed the input to 1. We are expecting the output to be 1. But still it is 0. After a fraction of seconds, after a fraction of nanoseconds, it became 1. Now we are saying that fraction of amount of time, when I changed the input from 0 to 1, what is the time taken by this digital logic circuit to change the output from 0 to 1? That time is called as a propagation delay. So generally we hear the wave propagation, wave propagates. Similarly, it is the time taken by the digital IC when a pulse propagates, the mean time taken by the pulse to travel through IC. Okay, generally it is represented by using TP, propagation delay, because it is time. The units seconds, because it is time. We have seen different logic families. Out of all those logic families, emitter couple logic is having the very less propagation delay. Very fastest logic circuit is emitter couple logic. Whether it is saturated or non-saturated, emitter couple logic. Non-saturated. That is why it is very fastest. There is no need to go to the saturation. When it is in active region, we will consider that as a 1. That's why very fastest digital logic circuit is ECL. The propagation delay is very less, in the range of the 3 nanoseconds. Okay, out of the all logic circuits, which is the very fastest? Emitter couple logic. Okay, what is the propagation delay? Propagation delay tells the which parameter, whether it is telling the speed or life or power, or which parameter it is indicating? Speed.